This tutorial discusses the different types of file-based backups. Some backup systems use a snapshot of the blocks on a hard disk, but the three types of backups here operate on individual files. The three main types of file backups are called full, differential, and incremental. To understand how all new backup programs work, one first needs to understand how these three types of backups work. So how does a backup program know what files to back up? To do this, there needs to be some mechanism in the file system to determine when files have changed. Well, there's two methods that are currently employed to determine this. Microsoft, using the FAT file system and NTFS, can use what's called an archive bit. In these two file systems, every file along with it has a bit called an archive bit. Now, every file typically has a number of bits that are stored with it that indicate different things. For instance, you have a bit for a hidden file which shouldn't be displayed to the user. A bit may indicate a locked file or a system file. So one bit is called an archive bit. The archive bit indicates that a file has been modified, and that's controlled by the operating system. So whenever a file is created or whenever it's changed, this archive bit gets set. Now, how do we look at the archive bit? Well, if you look on a Windows system and look at the properties of a file, so what we've done is we've taken a file here called EasyBCD, and we've looked at the properties of the file. And if you go to the Advanced tab, you will see a little checkbox that says this file is ready for archiving. That's really showing you the status of the archive bit and is saying that this file has been modified. Now, along with an archive bit, almost every file system stores timestamps, and what you'll see here are three timestamps for when the file was created. It'll be the day, the date, and the time. So you'll notice under here this file was accessed at 9:18 and 17 seconds in the morning. So you have a created timestamp, modified when this file was modified, or an accessed. So these are the different systems that can be used. Not only do you have an archive bit in Windows, but what if you're using Unix and Linux? Unix and Linux don't have an archive bit, so instead they use this timestamp to determine, the backup programs use the timestamp to determine when files should be backed up. Some new Windows programs use this system as well. It's called a change journal, and along with every time they back up a file, they keep track of the time and date that it was backed up, and they use this to determine whether new files should be backed up. Now, only one program can use the archive bit method. If you have a local software backup program A that's backing up files, and if you're in an organization that also has a different software backup program B, maybe it works over the network, but it also backs up your files, if they both use the archive bits, things can get confused and your backups won't work properly. So one disadvantage of using the archive bit is that it can only be used by one software program at a time. The change journal can be used by multiple programs. For describing the three types of backups that we're going to talk about, I'm going to use this archive bit concept, but the explanation is identical whether we're talking about using timestamps to determine if a file has changed or whether we are using the archive bit. So we're first going to look at full backups, and every one of the little squares here indicates a file. So let's suppose this is the status right here of my file system. And I have 4 files, and the archive bits are in different states. Well, in a full backup, we basically back up every file regardless of whether they've been modified or not. So regardless of whether the archive bit is changed. So what happens is we have all those files are put together, and often they're put together in a single file called a catalog. Sometimes This may be compressed depending on your software, if your software can compress it for saving storage. And in the file system itself, all these archive bits are cleared. So we're backing up all the files and we're clearing the archive bits. So in our file system, the changes occur to just the archive bits, and we produce this backup file, which is called a catalog, and it usually has a timestamp. So this is a full backup catalog here, and it's often contained in one file just to make it easier to access. Now, backups, you can do a full backup on your system every time. However, full backups are very large, so they take up a lot of room and they're slow. The advantage is they're very complete. So if you're not backing up very much stuff and you don't have things which are changing, you could do a full backup quite often, but typically full backups are only done once and then you employ some other backup system. So we're going to look at one of two different backup styles that are employed along with a full backup. So the first one we're going to look at is what's called an incremental backup system. And this is our file system. We have a lot of different examples of our file system here. Just going to look at this little example here. Now we have, these were our 4 files that we had done a full backup on. So I have a backup catalog that is here that contains a full backup. So it's a single file, but it contains full backup. That's the type, and we'll just call it number 1 because it was the first backup that we had done, but it was a full backup. So we backed up all those files and then we cleared the archive bits. Since then, we've made 2 changes. We've added the red file and we've added the purple file, and so the archive bits are set. So what happens in an incremental is that we back up files that have changed. So we look at the archive bits, or we look at the timestamps if we're using Unix, and we back up only those files. So here we have 2 files with the archive bits set, and this is going to be in our next catalog. So this might be the next day. So after a full backup a day later, I added these 2 files. Maybe there were 2 Word documents I created and the archive bits were set. So when I did my incremental backup, so I create a new catalog. I'll just call it incremental because that's the file type. I'll call this number 2 because it's the second backup type that I've created on day 2. And what happens after we do the backup is that the archive bits of the file I've backed up are cleared. So we get this state. So our file system is in this state. Now on day 3, maybe we've modified this blue file. So that's why it's 2. It's a sort of a new version number 2. Maybe it's a Word document and I've added a paragraph of text. So therefore, since it's been modified, I have the archive bit set. You'll notice that there was an orange file under here, but I deleted it. So it's gone from the file system. We also updated our purple file. We've changed that, so the archive, and we've added a new file. So what would the incremental do? It would back up all files that have changed. Well, the files that have changed are the blue file, the purple file, and the light blue file. So this is another single file, a catalog. It's an incremental type, and it was made on day number 3. On day number 4, we make another change to a purple file. We've modified this file again. You'll notice that we have no blue file, so we've deleted a blue file, and we have added a lime green file. So my backup catalog on this day would be these two files. So I would have another backup file or catalog, which would be incremental, and it's made on day number 4. Now after these incremental backups are done, all these archive bits get cleared. I haven't really shown that here. So one of the things we notice about the incrementals is that they are small. Each incremental backup can be small, just the files that we've changed. It's pretty fast to make an incremental backup. And now we want to restore. So that is, we've lost, maybe our file system now up here has died and I need to recover this. And I have my backup catalog somewhere rather than my machines. They're usually stored off-site somewhere. So how would we restore? Well, in a full backup system, you simply need to restore just the last full backup. When you're using full backup with incremental or with differential, you need to make sure that you back up some of the incrementals or differentials as well. Now, in the incremental system, what you need to do is you first back up the full backup. So when you restore, you first do the oldest full backup, or the last full backup. You then need to restore every incremental, and so the restore can be a little slow because you've got to go through every incremental file. So we've restored this blue one here, brown, green, orange, using the full backup. I then restore incremental number 2, and I restore the red one and a purple one. I now need to restore incremental number 3. So what happens is the blue has been modified, so it overwrites the old blue file, and I get version 2. I get version 2 of the purple, and I get a blue file here, which is restored. Then I restore incremental number 4, which gives me the latest version of this light purple, and it gives me a green. So when I do a full restore, these are all the files which get restored. Now let's compare this against what was in the operating system just before the crash. Do I have all the files that I lost? Yes. I have this blue 2 and brown, light green, lime green, version 3 of this in red. Now, in order to make sure you've got the right version of every file, you got to make sure you restore the incrementals in the proper order. You've got to go to the oldest incremental first, and then work your way to the newest incremental. You'll also notice you'll have some extra files. That's because this system can't keep track of things that you've deleted. So you've deleted an orange file back here, but you had stored that in a full backup, so you still have it. So you may have some extra files. That's not really a bad thing. The most important thing is that you haven't lost any data. So that's how an incremental works. You basically back up files that have changed and you clear the archive bits. And that's what happens every time you make an incremental. And usually full backups are made, say, once a month, and then for the next 30 days or 29 days you may just use incremental backups. And then you would do another full backup and then incrementals. So you only need to go back to the last full backup you've done and then the incrementals since then. Now, how does differential work? Well, a little different. Again, we've done our same idea here where we have our file system and we've made a full backup. So again, we typically start with our full backup catalog on day number 1. And I have added 2 files. On day number 2, I added a red file and a purple file. Those have the archive bits. So what a differential does is it back up all files that have changed. So in this regards, it's like the incremental. So my first catalog is the same as my incremental. However, it's using a differential method, so I'll call it DIFF. And this is on day 2. Now, the biggest difference is that the archive bit is not cleared. So it's not changed at all. Whereas in the incremental system it is changed. So those archive bits stay set. Now what happens is on day 3 I've changed something in this blue file, I've changed something in this file, I've deleted an orange file, and I've added a new file. Well, if I look at all the archive bits which have changed, okay, I added a file here, this changed, modified this, so the archive bit changed. This archive bit was set from before, so it still stays set. So I have 4 files here that are in my set for the next day. So this is the next day's single catalog on day 3. On day 4, I delete this blue file here, I add a lime green file, I update this file here, and you'll notice that these two here, those are still set from before, because remember, we do not change the archive bits. So now if I look again, I have 4 files in my catalog for day number 4. So when I'm backing up, some of the things that we'll notice is that the differential sets, they grow in size. They typically vary, unless we're deleting a lot of files that have their archive bits set, they typically are always larger than the one before. So it takes more space than an incremental, but not as much as a full backup. The nice thing is in the restore. Whenever I'm restoring, I go back to the last full backup. So I need to back up the full backup, which I've done here, 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 and here. And then I only need to go to the last differential. I don't need to process all the differentials in between. So the restore is fast. So I now put the blue 2 version of the blue file. So that overwrites here. I have the purple 3, the lime green, and the red. And what you'll notice is if I lost everything in my hard drive, how close was my restore to what was here? Well, it's actually a little closer than the incremental. The incremental could not track any files which were deleted as we were doing differential backups. Here we have 1 extra file, but if you go back and look at the incremental, we had a couple extra files. So this is a little truer when you're deleting files. It's going to be a little more accurate than the incremental. But again, another system which will make sure that you do not lose data. The restore is faster. You only need to go to the last differential method. It does chew up. These backups do take up more disk space. So let's compare the various methods here. If you do a full backup every day, as is shown here, you'll see that your backups typically grow as you add files and change things. So in a full backup, all data is backed up. It's the slowest method. The restore time is the fastest because you're just going to the last full backup. You don't need to process anything historically. The storage space, though, is extremely high, and most systems don't use full backups every time they want to back up. If we're using an incremental system here, you typically would do a full backup and then just files that change. So they change in size each day depending on how many files you've modified. It's the fastest backup time. The restore time is moderate because you've got to process every incremental backup set. But the storage space is the lowest. So it takes up the lowest amount of hard drive space. The differential here, Again, starts with a full backup. The differential sets grow, so all data since the last backup. The backup time is moderate because the incremental is just backing up smaller amounts of data, but in differential you're growing each day usually, so it takes more time to do the backup. However, the restore time is fast because you need to restore the full backup and only the last differential. Storage space is moderate, so it's somewhere in between full backup and incremental. So this is a comparison of the three backup types. You should be able to define what the difference is between a full backup, differential, and an incremental backup.